Okay. Let's start again. Great. Okay. All right. Perfect. All right. Good morning, by the way. I'm Miss Wong. I'll be walking around, so you probably won't see me. So, dengar agak suara saya? Since we are having a very good distance over here, and therefore I won't be using the mic and my mask, definitely. Okay? So for today's topic, we'll start with your topic 1.2 collision theory, and we will finish off with your topic 1.3 factor affecting your rate of reaction. Okay? So talking about your collision theory is a very simple and short theory that we are going to discuss a few new terms. Okay? First and foremost, what is actually collision theory? Collision theory, as you all know, ada dalam nota, bacalah, blah, blah, blah. The key words yang saya nak bila kamu ada explain what is collision theory, there are three things. By the way, is everybody here? Kawan-kawan kamu semua ada kah? Tak apa, nanti saya akan kira. Okay? Where we are, collision theory. Ada 3 benda yang kita boleh akan hasilkan produk. Before this, in our syllabus, kamu kata kalau saya nak ada reaction, saya nak ada produk. Kena berdiri sini. Alright? Kalau dia nak ada produk, kita kena ada reactant. So what you know before this, to get a product, you need a reactant. But to go deeper, having the reactant but doing nothing will not give you product. Okay? Now buat cake, kamu ada telur, ada tepung, ada gula, but you do nothing to them, you will never get the cake. Okay, you want to get A, you have the notes, you have the book, you have everything, but you didn't work for it, you will never get the A. Right? So, in chemistry, there is 3 requirements for you from the product moving to the reactant. The first and foremost, the reactant must collide. The molecule in the reactant must collide. Bila kamu ada acid and base, alright, bila kamu ada base, kamu ada acid. Saya bagi contoh yang senang. So, pacik ni duduk dalam satu beaker, pacik ni duduk dalam satu beaker. Boleh tak produk terhasil jika diorang duduk dalam beaker yang berbeza? No. So, what we are going to do, we are going to mix them up into a new beaker. Kita akan campur dan kita akan tuang dia dalam beaker yang baru. Supaya the molecule can collide with each other. We are not saying hi and bye. Dia tak boleh say hi and hello and you get the product. No. In chemistry, you need to have collision. That's why you need to have energy. So the energy that we are talking about, definitely kinetic energy. Alright? Because we are talking about collision, we are talking about the molecule colliding each other. Dia nak berlanggar, so dia kena ada apa? Kinetic energy. And I'm using the word minimum kinetic energy over here. Kalau kamu nak dapat A, that is a minimum work to get it done. Betul? Kalau kamu nak dapat cake yang sedap, there is certain step that you need to do to the egg, to the flour, to the sugar. I'm not a good baker, by the way. I never bake anything. It just is a very simple and things that I can use, okay? There is certain rules that you need to apply, and then you can get a good egg, a good cake. Pick it up, pick it up. Because the things that drop is a calculator, am I right, boy? If it's a phone, you'll pick it up immediately. Alright, where we are? Kinetic energy. Alright, cake. Alright. So, you must have the word minimum. Budak selalu akan kata, oh dia kena ada kinetic energy. No. Kalau untuk dapat A adalah 80 maka 79 will never give you the A. Kalau minimum kinetic energy yang saya perlukan adalah 100 kilojoule, 99 kilojoule will not give you the product. Is that clear? Okay? Perkataan minimum jangan tinggal. The minimum energy that we are talking about mesti berdasarkan something. Bila kita kata dapat A adalah 80, maka dia akan berdasarkan 80. Itu adalah skala matrikulasi. Kalau pergi kat uni, skala dia 75. Do I look good? Dulu kat sini dia orang kuliah, dia meja panjang. So, saya pakai shorts pun tak nampak. Tapi sekarang do I look good? Not bad, right? Okay. Yang penting rambut kena cantik. I'm just joking, but thank you for laughing. Where we are? Tengok, buat lawak bodoh tu, tempat tu lupa. Activation energy. So, bila kita kata minimum kinetic energy, dia kena based on something. Okay, kalau grade kita based on the skill yang kita adalah di matrik. Dan kalau kat sini, the minimum kinetic energy is based on one thing, activation energy. Okay? So we are going to talk about what is activation energy later on. So the minimum kinetic energy which is equal or more than activation energy, dan the symbol that I love to use untuk dalam nota ataupun untuk kamu hafal. Jangan guna simbol untuk explain. Only for short notes where the kinetic energy must be more than or equal to your activation energy. Okay? Dan sekarang tenaga dah ada. Okay, molekul dah duduk satu beaker yang sama. Alright, molekul dah duduk satu beaker yang sama. Tenaga dah ada. Tapi kalau langgar tak kena, still takkan dapat produk. When we are talking about collision, there is one thing. Right orientation. Alah, timing tak kena. Bahasa apa? Kalau jumpa, aku suka je dia. Tapi timing tak kena, tak ngam. So tak apa lah. Macam tu. Betul tak? Okay. So it's always about the timing, it's always about the orientation. Katakanlah, wow, somebody is late. Tak ada. Bunyi apa? Macam ada hantu je. Saya tak ada pen, saya tak ada apa. Oh, I got marker. Alright. So, the right orientation, katakanlah, the correct orientation to get the product adalah collide like this. When you collide like this, you get the product. So, bila dia berlanggar pada correct orientation, tenaga yang cukup, dia langgar, dia akan lekat jadi produk. Tapi kalau tenaga cukup, berlanggar, but at a wrong orientation, dia berlanggar, tenaga cukup, tapi dia langgar macam ni. So, dia still takkan dapat produk. Betul? Ataupun, dia berlanggar betul, tapi dia berlanggar slow gila. Tenaga tak cukup. Dapat produk tak? So, all three requirements must be fulfilled. With the correct orientation, they must collide and they must have the minimum kinetic energy that is equal or more than activation energy. Baru dapat product. So getting a product is no longer about having the reactant. It's about having the reactant and how do they behave. Okay? So that is your collision theory. The main thing about collision theory satu je, saya nak dapat produk. Saya nak reaction saya jadi dan dapat produk. That is the main purpose. Okay? Saya nak reaction saya jadi dan saya nak dapat produk. So, activation energy, I'm mixing with Malay. Is everybody happy with that? I can speak full English if you want. Lagi, apa ni kan susah. Saya cakap full English pun hampa complain. Saya cakap campur BM pun, Miss Song ajar campur BM. You want to try? We can use full English. Nothing can please you. I don't know what can please you. Tapi so far saya kena complain to Ted Sam lah. So I'm fine. It's okay. Alright. Where we are, activation energy. Okay. Activation energy is the minimum energy. Contoh yang saya bagi paling senang, simple. 80 marks is A. Getting 79 is not A. Alright. That is activation energy. That is activation energy for you to get the A. So in chemistry, we have activation energy like I say, if I have a reactant, and for this particular reaction, the reactant to get the product, the reactant must achieve equal or more than, let's say, 50 kilojoule. So, kalau tenaga reactant saya tak capai 50, my reactant only 40 kilojoule, do I get the product? No. That's why sometimes the reaction, you need to heat it up. Kamu kena panaskan dia. Why? Because you want to provide energy. So, when I heat up the reactant, alright, when I heat up the reactant, what happened to the reactant is the reactant gain kinetic energy. So when the reactant gain kinetic energy increase. It will then be more than 50 kilojoule. So when it's more than 50 kilojoule, then only you can get the product. Nampak? That is minimum kinetic energy. That is what we call activation energy. And the main thing, why we want to go why we want to go above activation energy. Satu je. I want the reaction to happen. That's it. Semua ni, the entire thing about collision theory satu je. I want the reaction to happen, not only happen, to get the product. So when you have the minimum kinetic energy needed by the reactant, in the correct orientation of collision, you will then initiate the reaction. Barulah reaction kamu akan bermula. Sayang, I know in chemistry, this thing is something that you need to imagine. In the lab, this thing happen in probably 2 seconds. Acid base tuang dalam beaker, dia tukar color, dapat garam. Betul? This thing happens, but it happen in a split of second. Okay, so what happened in that 2 seconds is this. Okay, alright, great. Saya tak sure sebenarnya suara saya akan okay ke tak, cukup kuat ke tak. I try to be as loud as I can. We'll try for this first recording, then we'll see how it goes. Okay, so next, transition state. From the word transition, what do you think? Change. Okay, we talk about cake just now, right? So saya ada tepung, I have flour, I have eggs, I have sugar, probably the cheapest cake that you ever bought. And then you want to get the cake, right? But from the flour, the egg and the sugar, can you get the cake immediately? No. Can I put the flour, egg and the sugar in the pan and then I chuck into the oven and I get the cake? You guys are very nice to me. Last time saya cakap statement ni, lepas tu dia kata boleh kita ada mixer. I'm like, sounds yes, I mean, yeah, but yeah, thank you for saying no. Saya serius, boleh teacher, kita ada kitchen aids, kita boleh masuk, dia boleh dapat terus. And then I'm like, yeah, but there is still transition state in that kitchen aid, which is they will still mix your egg, your flour and your sugar to become one thing that we call batter. Betul? Kamu akan ada adonan dia. Adonan is the transition state. This process, this place, alright, is what we call transition state. Sayang, transition state adalah satu tempat, bukan satu benda, satu kawasan. So saya nak ubah sikit, this is the location, this is the process. Okay? So what is the batter? The batter is what we call activated complex. Transition state is that position, tempat tu. Siapa yang duduk dalam tempat tu? Activated complex. Betul? So, before you get the cake, you got the adonan. Adonan tu adalah what we call your activated complex. And at this adonan, soalan saya satu je. Is that already a cake? No. Is that still the egg, flour and sugar? So, lepas mak kamu dah campur dengan tepung, lepas tu saya suruh, keluarkan balik telur tu, lebih sedikit. Boleh tak? So, my question again, is that a cake? No, not yet. So, in the other word, not yet the product. Betul? Next question, is that still the reactant? No. So, what is activated complex? Activated complex is something that is not yet the product. It's not yet the product. Dia bukan produk lagi, but it's no longer the reactant. Betul? Sayang, kenapa nampak sedih je? Nampak boring je, tak suka ke? Baru kelas setengah jam dengan saya, tak sampai setengah jam. You look boring, you have 16 more weeks to go. God's sake. Come on, girls. Hang nak berlakon pun berlakon semangat sikit. Walaupun dalam hati tu tak semangat, tak apa. Tapi berlakon. It's okay, everybody act in their life. Your entire life is a drama. My career with you is another big drama. Hang aku suka gambar, aku tak suka weh, jujur. Kenapa sonok sangat? Because it's Saturday, right? It's quite sad. Okay. So, tadi kita dah bergerak ke activated complex. Kenapa kat transition state tak lama? Transition state adalah satu tempat. Dalam produk, dalam reactor nak jadi produk, tengah-tengah tu kita ada satu tempat panggil transition state. Yang saya nak cerita, what we are going to discuss is actually what is sitting in the transition state, activated complex. That we know what is the activated complex, saya nak bagi tahu satu, is not reactant already. Okay, dia bukan reactant dah, but not product yet. Dia bukan produk lagi. Okay, so dia duduk kat tengah-tengah. Kamu nak kata dia telur tepung gula? Tak, aku tak nampak dah telur tu. Tapi kalau pakcik tu boleh keluarkan telur tu, aku kagum lah. Alright, dan boleh makan terus? Tak boleh makan lagi sebab dia bukan jadi kek lagi. Betul? So dia bukan dua-dua, dia duduk kat tengah-tengah. That is what we call activated complex. And you know what? Activated complex is extremely unstable and has a very short life. Okay? Dia adalah sentiasa benda yang paling tak stabil, benda yang paling tinggi tenaga. Have the highest potential energy. Kenapa have the highest potential energy? Sayang, dia bukan reactant, dia bukan produk, tapi dia adalah campuran. So dia adalah tenaga dua-dua. Alright? Dia tak jadi reaktan dah, tapi dia tak jadi produk lagi. So, dia akan ada tenaga sebahagian daripada reaktan, tenaga sebahagian daripada produk duduk kat dia. So, tenaga dia sangat tinggi. Dan yang paling penting, dia tak stabil. Okay, dia sangat tak stabil. Kalau telur, tepung, gula tak campur lagi, dia boleh duduk dalam fridge, tak rosak. Setengah tahun tak rosak, saya. Betul? Alright? Bunyi apa tu sebenarnya? Bunyi sebelah. Ada orang buka? Tak betul bunyi? DK sebelah, kita kat DK 1, DK sebelah kat sana. Tapi bunyi kat sini kan? Tu aku cakap macam ada hantu. Hari Sabtu hantu punya tempat ni. Kita main mengacau betul lah hari Sabtu buat kelas. Betul tak? Oh my god, it's a recording. Jangan bagi kat kawan. Hampa tengok sini. Baby Yes. Kalau saya ada telur, gula dengan tepung, kita letak, kita simpan kat store, it can last. Alright, when it can last means the half life is very long. Dia tak rosak. Kek yang dah bakar pun, kamu kalau simpan dalam fridge, simpan dalam freezer, potong dengan knife yang elok, alright, bungkus dia betul-betul, you can keep for about 1 or 2 weeks. Betul? Tapi adonan tadi, the batter, the mixture of the batter, tahan tak? Boleh tak dah campur, lepas tu cakap aku tak ada mood nak bakar, aku nak letak dulu, nanti 2 hari baru aku bakar. Boleh tak? Short half life. Very short half-life. Dia cepat rosak dan dia takkan tahan lama. The short half-life means it wouldn't stay there for so long. Alright, it will be there. Ada dah benda tu. Dia wujud tak? Dia wujud. Tapi dia takkan duduk lama. Alright, sebab short half-life dia akan hilang. Dia akan pecah jadi benda lain. Dan obviously, transition state yang ada activated complex bergerak daripada reactant, transition state yang pegang activated complex, dan kalau dia tak nak duduk kat sini, dia pergi kat mana? Produk. Dia akan pergi ke produk dengan syarat cukup tenaga. Collision betul, energy cukup, baru dia jadi produk. Bayangkan adunan tu masuk awan tapi tak buka Swiss. Betul kan jadi kan? Ataupun masuk awan, buka Swiss tapi lupa check temperature. Jadi tak? Same thing. So saya ada reactant, saya ada activated complex, kalau tenaga cukup, remember collision theory? Tenaga cukup, correct orientation, ada collision, bergerak terus jadi produk. Tapi kalau tak cukup tenaga, or a wrong collision, ataupun dia tak collide pun, okay, what happen? Dia jatuh balik jadi reactant. Sebab dia duduk tengah-tengah. See that? Okay, make sense? Happy? My lecture, ayat baca sendiri macam biasa. Masuk kelas saya bagi je ayat tu, hampa bacalah ayat tu dan nota. Kalau nak baca ayat, tak payah masuk kelas saya. Kalau saya masuk baca ayat je pun, hampa kata kutuk aku juga kan. Ni semua baca slide. Betul? So, saya tak bacalah slide tu. Boleh? Okay. So, that is your activated complex. Is formed when the bond in the reactant are breaking. Saya ada reactant. A dengan A, tambah B dengan B. Okay. Produk saya nak A, B. So, what happened is, the bond in the A is partially breaking. The bond in the B is partially breaking. And the bond between A and B partially forming. That, saya patut lukis kat tengah lah kan? Tak apalah. Okay. That is what happened. The A and A partially breaking. The B and B partially breaking. Tapi the AB is partially forming. Saya nak lukis lain, tak muat. So my my AA, my BB, that is partially breaking. Sebab dia reactant kan? Partially break. Pacik ni pun sama, partially, God's sake. Pacik ni pun sama, partially break. Okay. And then what happened is, I have A and B bond forming. Tapi tak jadi solid line sebab dia partially forming. Nampak? Everything doesn't listen to me. Okay, perfect. Question? Senang. Dia konsep yang sangat senang. Untuk saya dia konsep logik je. Tapi konsep logik tu kena ada term science yang kamu guna untuk explain. Okay? So, happy with that? Okay, moving to the last thing of 1.2. Energy profile diagram. kita nak tunjuk kedudukan reactant, product, activated complex, transition state dalam satu tempat. So kita akan guna energy profile diagram. Before energy profile diagram, satu je. How many type energy profile diagram we have? Which are? Exothermic and endothermic. Semua orang tahu exo, delta H equals to negative. Delta H adalah negative. Sorry for my bad writing. I tried, but it's still bad. Okay, but it's readable, I guess. Okay, it's not that bad lah. Okay, betul? Soalan saya, why positive, why negative? Release heat, absorb heat. Lagi? Mathematic wise, chemistry wise, yes, the system is releasing heat or the system is absorbing heat, right? Mathematic wise, tahu tak delta H reaction ni dapat macam mana? This positive, negative, yes? Thank you. This one, delta H negative ni is actually delta H reaction. Reaction punya lah, total saya dapat negatif. Kenapa total dapat negatif? Because of the total product, okay, minus total reactant. Dan sayang, kita tengok untuk exo sahaja. Saya jadi student, saya malah nak hafal. Saya kalau ada dua benda 50-50, kalau dia positif, dia negatif, saya hafal satu je. Alright, tapi still dapat A lah, still pandai lah. Still jadi cikgu. Jadi cikgu tu tak adalah pandai, tapi still survive lah. Okay. Exothermic, saya hafal satu je. Ikut kamu nak hafal exo ke endo. Okay. So kalau kita tahu exothermic adalah negatif, dan we know that the negative because product minus reactant. Sayang, negatif. Siapa tinggi? Reactant tinggi. So your reactant over here must be higher than your product. Simpan benda ni. Okay. Sekarang exo reactant higher than product. Ingat yang ni ya. Exo reactant higher than product. Saya nak bergerak kepada lukis. Okay. Bila kita lukis, if you remember, this thing is energy. Okay. And energy normally in kilojoule lah. This thing is the reaction progress. Reaction process. Ada bunyi kan? And sebelah sini kan? And tak tahu pintu mana kan? God's sake. Sorry, we are taking your time. We are taking your space. Tadi, exo. Produk tinggi ke reactant tinggi? Reactant. Bila reactant tinggi, paksi X kamu adalah reaction process. Dan reaction process kita baca dari kiri ke kanan. Kiri ke kanan bermakna kita bermula dengan reactant. I'm showing you butt, my butt. Sorry. I forgot. Tak biasalah, nanti saya cari cara lain lah. Yang better. So, kita bermula dari kiri ke kanan. Reactant duduk kat atas, lebih tinggi daripada produk atau reactant duduk lebih rendah daripada produk? Kat sini tinggilah sebab nota duduk depan mata. Dalam exam nanti nak fikir macam mana. Reactant mula. Dan kita tahu untuk exo, reactant kena lebih daripada produk untuk dapat negatif. Tu cara nak hafal. Okay, bukan hafal diagram tu. So, reactant kena tinggi. So, dia duduk tinggi. Forgive my drawing. Dia turun. Produk kena duduk bawah. Betul? Untuk soalan kamu, untuk nota kamu, dia label dengan reactant dan produk terus. Betul? Saya nak buat cara lain. Saya nak label exo. Exo means release. Release means bond forming. So, I want to do this. I want to give you the reaction straight away. Okay? So, I'm giving you the reaction with ammonia. Formation of ammonia adalah exothermic. So, delta H adalah negatif. So, kalau soalan suruh lukis untuk the particular reaction, yang ni yang akan keluarlah dalam exam. What happened? Don't label reactant product. Label with the reactant product. Jangan label perkataan reactant product. Knowing that this is your reactant. So, what you should label on the reactant is N2, 3H2. Okay? 3H2 pun boleh. Lupa the gas. 3H2 pun boleh. H2 sahaja pun boleh. The energy profile diagram, stoichiometry tak penting. Yang penting siapa reactant, siapa produk. Dengan kata lain, chemical equation dalam drawing tak perlu balance. Okay? And then turun kat bawah adalah produk. Nak senang, tulis je lah. Yes. That is what I mean. Okay? I believe this thing is something that you've been drawing in your form 4, form 5. But in your form 4, form 5, you only label with reactant and product. Okay? And then you are done. A few things that you need to label in here. First, activation energy. Always remember, activation energy adalah daripada reactant sampai kat puncak. Reactant, that is my reactant, okay, sampai ke puncak, the highest potential energy. The highest potential energy, puncak kamu, that is my activation energy. Okay, saya nak lukisan yang tu dulu, that is my activation energy. Next, ke bahagian bawah pula, dia mesti adalah puncak, dengan bawah ni akan ada satu line, di mana dia ada dua arrow. Arrow kedua adalah antara reactant dengan produk. Sayang, dalam dunia ni ada satu benda panggil ruler. You use your ruler. Okay? Daripada reactant sampai kat produk, this part, what do you think it is? Delta H. Dan I don't want delta H only. I want delta H equals to negative. That's why you know it's an exo. Benda ni keluar kalau kena label, kena lukis, 3 markah free for me. Okay? And this is what you learn in your SPM. So in here, one extra thing. The only extra thing that you have in here adalah transition state. So kat sinilah kedudukan transition state kamu. So what do you label? Activated complex. Perkataan yang kamu akan label. Activated complex at transition state. Yang tu yang kamu kena label. Okay? And this is the extra place. Okay? So kamu nampak kenapa dia adalah activated complex at transition state? Sangat-sangat senang. That is your reactant. Reactant akan naik tangga. Saya guna perkataan naik tangga. Dia bukanlah naik tangga. Dia akan gain energy. Dia akan kumpul tenaga dia sampai dia cukup. Sampai dia akan sampai ke activation energy. So dia dah sampai kat puncak. So apa jadi bila dia sampai kat puncak? Dia akan start berlanggar in the correct orientation. So yang berjaya langgar dengan betul, that have a correct orientation of collision, dia akan golek turun bawah jadi produk. Apa jadi kalau dia berlanggar tapi wrong orientation? Dia akan golek balik ke bawah jadi reactant. Nampak? Okay? So that puncak yang paling tinggi is what we call transition state. A moment yang akan tentukan dia jadi tak produk. Okay? So that is how we label. Make sense? Simple. Exactly the same thing. Oh, by the way, just a bit of tips. Kenapa tadi saya kata the formation of ammonia kat sini adalah exothermic? Selalunya proses, kadang-kadang pernah keluar dalam exam, dia tak bagi tahu dia delta H atau delta H positif atau negatif. You need to know some basic knowledge of this. If you involve bond forming, if you realize why I say bond forming is your N2 combined with your H2 to produce one compound. Bond forming, betul? Can you see the bond forming? Normally, delta H negative. Energy will be released. Kita tak perlu tenaga yang banyak sebab kita hanya nak tarik dan lekatkan diorang. Okay? Vice versa of your endothermic. If the bond forming just now is an exothermic, endothermic will be bond breaking. A very simple bond breaking is your water, all right, breaking into your hydrogen gas and also your oxygen gas. So if you involve something like this, your bond breaking, this guy, H2O, all right, pecah jadi hydrogen gas, pecah jadi oxygen gas. You can see you involve one thing, bond breaking. So when the thing is already bonded, you know. When the thing is already bonded, what you are trying to do is I want to break the bond that is already there. So you need energy, betul? So when you need energy, then it will be your delta H positive. You need to absorb the energy. Some basic knowledge on how to determine which one is your endo, which one is your exo. You need to know. Okay, sebab kadang-kadang soalan simple like this, dia tak bagi delta H, but you need to discuss the energy profile diagram. Okay, so similar, vice versa kalau tadi reactant tinggi, sekarang reactant rendah. Jangan lupa label, guna pen merah, jangan lupa label your paksi Y sentiasa adalah tenaga in kilojoule, over here adalah reaction progress. Okay, so jangan lupa yang ni, dan seperti yang kamu setuju tadi, dia akan duduk kat rendah lah. So daripada rendah, forgive my bad drawing, got sick buruknya. Perlu elok sikit Okay. Alright. Saya nak dulu saya kena duduk. Okay, so put down your reactant. My reactant over here is my 2H2O gas. Yang ni tak ada apa. So saya ada my product 2 hydrogen gas and oxygen gas. Apalah peduk jatuh banyak tu. Nervous kak? Relax lah, aku tak tanya soalan lagi pun. Saya tak suka pun datang tu lukis kat depan. Relax. Okay, so very simple over here. First and foremost, what do we need to label? Activation energy. My question, activation energy dari mana ke mana? Reactant. Always ingat, tak payah hafal apa pun. Tak payah hafal, jangan hafal jarak. Hafal satu je. EA duduk kat mana? Reactant sampai kat atas. Okay, hafal yang tu je. Saya ada reactant. Cari reactant kamu. Saya ada reactant saya duduk sini. Alright. Puncak saya sini. So, puncak dengan reactant, beza dia adalah EA. Okay, next. What else do we need? Delta H. Delta H forever antara reactant dengan produk. Carilah reactant saya dah ada. That is my reactant. Ni adalah produk saya. So reactant and product adalah delta H. Can I leave it here? What do we need to put in? Perfect. Alright. Positive. Simple. Are we done? What else? Activated complex at transition state. Label macam ni je kat puncak. Activated complex at transition state. Oh, by the way, good news. Kalau ada siapa yang nak tanya, teacher dia akan minta tak lukis activated complex. No. Kamu tak belajar lukis kompleks dalam silibus kimia. Okay, kalau masuk degree ambil sains, ambil kimia lagi kita belajar lah. And it's disaster. Sampai sekarang aku ada yang tak nak lukis. It involves a lot about bond flank, bond breaking, energy dah sampai mana, ikatan mana yang patut putus. A lot of those things lah. Okay. So activated complex kita hanya perlu tahu dia duduk kat mana, kita hanya perlu tahu dia tu apa and we are done. Okay? And I think energy profile diagram is something very simple that you come across in your life. So if this thing coming out in your final, do not miss any marks. Okay? Sebab hujung kelas nanti kita ada satu lagi graph yang baru. Kalau nak hilang markah yang susah, yang tu susah lagi. Dia tak susah tapi dia benda baru. This simple. Satu benda je tambah. Label reactant, label product, label activated complex at transition state. And you are done. Betul? Simple. Happy? Any question for 1.2? No? Okay. Very, very simple stuff. Tak ada apa. Dia logic. But as I said, the logic using science term. That's it. Okay? So, next. Kita nak masuk 1.3. Yang ni kita nak start tanya banyak soalan lah. I hope I can walk around. Okay. Alright. First and foremost. Pakcik, hang apa tak? Hang apa? Tak salah, I never say you're wrong. I couldn't believe your logic. That's it. It's definitely my bad. It's definitely my question. You never do wrong in your life. Apa-apa salah miswak. Alright, kalau kamu dapat A sebab kamu pandai. Tapi kalau kamu tak dapat B, A, miswak tak pandai banyak. Okay? That is always about me. You never do anything wrong in your life, don't worry. You can always put the blame on me. Definitely. I correct my question. I'm not asking you by the way. Yes. H3? P3. A or B? B. Saya nama apa dah? Nama apa dah? Azim. Azim, first question. How many factors that affecting rate of fraction we have today? 4. Okay, we are doing a spelling bee. Azim, give me one. Size of what? Particle size. So the first thing that Azim gives to us is particle size. Agree? Azim, bagi nama satu kelas kamu? Daniel. Yes, Daniel. Azim says size particles. Another factor? Sorry? Catalyze, betul? I don't know which English you learn, but I call it catalyst. Alright, but again. Saya cakap gambar apa? Delete gambar tu, gambar saya mahal. Dia cakap gambar bagi tahu, kena bayar. Dalam lecture saya, by the way, there is some rules and regulations in your face-to-face class. You are not allowed to take any recording or any photo And there's nothing on the screen, so it's definitely the flash. I don't know what's the flash about. But you nak tangkap gambar tapi you tak minta permission and you stupidly use flash. That is quite a stupid action. And delete that idiot photo. Nak tangkap gambar, what do you know? Today I dressed nicely, make sure my hair looks good. Daniel, yes, Daniel saying catalyst. We don't have oral catalyst, catalyze anything that you know what they are. Okay, next, Daniel, another one. Your classmate? Tak ada kawan ada. Classmate only. Okay, tak ada kawan. Let me pass to another class. Classmate yang laki. Alright, anyone that you know in this lecture hall? Okay. Cool. Yes, Mr. Cool. Another factor affecting rate of reaction. Temperature. Agree? Alright, we have temperature that will affect the rate of reaction. Mr. Cool, another guy? Another girl? Alicia. Siapa? Yes, Alicia. I have catalyst, I have particle size, I have temperature. Anything else? Concentration. Alicia say concentration. Agree, huh? Alicia, another one? Another one, I say another friend. Oh, your another friend is pressure. Pressure, yes, thank you. Thank you to Alicia. And Alicia said pressure. So, we have 5 factors affecting rate of reaction in your syllabus that you need to know. And other than just knowing the factor is not enough in your syllabus nowadays, in your level lah, not nowadays, in your level, we are not, kita tak main lompat jauh. Apa maksud lompat jauh saya adalah kamu belajar dulu kat form 4, form 5. Kamu hanya perlu tahu apa yang effect, dia tinggi atau rendah. That's it. Over here, we want to know why it affects. So you need to explain in detail. Alright, Arisha and Alisa. Alisa, I repeat my question. Another friend or another classmate. Who? Apa tak? Yeah, no way. You stand up. This is the time that the person that you hate, and I'm giving you permission to call his name. Pavisha. Right? Forgive me if I pronounce wrongly. Girl. Next question. How concentration will be affecting the rate of reaction? Or not how. We go simple first. Relationship. Okay? Concentration and rate of reaction. Are they inversely proportional or directly proportional? Directly proportional over here, ataupun I will use the word proportional lah. They not necessarily directly, depends on the factor. Okay? They are proportional where concentration increase, rate of reaction increase. Agree? Okay, we are looking into detail later on. Pavisha, another friend? Christina. Thank you, girl. Surface area or particle size. How does the surface area or particle size affecting the rate of reaction? Christina, very simple example. Garam halus dengan garam kasar. Okay? Surface area mana yang besar? Garam halus dengan garam kasar. Okay? So, surface area yang mana besar? Surface area garam halus akan besar. Tinggi. Agree, class? Okay? And then vice versa, garam kasar, surface area akan jadi kecil. Okay? Surface area akan kecil. Agree? Why? Which one is having bigger particle size and which one is having smaller particle size? Logik je weh. Garam kasar dengan garam halus. Mana yang nampak besar, mana yang nampak kecil. Particle size kan? Garam kasar akan nampak besar. Dengan kata lain, the surface, the particle size, okay, very simple, we just use garam. The particle size is big over here. Particle size besar. In the other words, particle size kat sini adalah kecil. Alright? So, before we go into affecting the rate of reaction, back to Christina. Christina, surface area and particle size, directly proportional or inversely proportional? Inversely proportional. So from here, you can see that the conclusion, when the surface area is large, okay, the particle size is small. Agree? Next $1 million question. Tak adalah $1 million. The main question. Garam halus, garam kasar. Christina, kawan lain. Kesian kat Christina jawab banyak lah. Bagi balik kat laki. Yes. Boy. So, in the other words, garam halus dengan garam kasar, siapa lagi cepat larut? Garam halus. Betul? So, garam halus akan jadi lebih cepat larut. This one will be the higher rate of reaction. So, in the other words, kalau saya nak higher rate of reaction, if I want my rate of reaction increase, means I need a smaller particle size because the contact surface area is larger. Okay? Lagi banyak contact surface area, lagi banyak garam halus yang boleh in contact with the water. So, dia akan larut lebih cepat. Nampak? Boleh? Agree, ya? Okay. So, pressure and volume. Ishak, kawan lain? Amir. Amir Aziz. Yes, Amir. Pressure and volume. Talking about just pressure and volume. Pressure and volume itself, directly or inversely? In my life, I always apply 3-second rules. Okay? So, sebelum makan pun orang baca doa, tahu kenapa? Alright, satu sebab nak bagi tenteram dulu lah supaya hang tak tercekik dan mati. Okay? Betul tak? Okay? Yang kedua adalah to check whether the rice is edible or not. So, calm yourself down, then you answer my question. Again, pressure and volume, inversely or directly? Inversely. Okay? When the pressure increase, volume decrease. Betul? Dan kalau saya nak rate tinggi, alright, Amir, kalau saya nak rate tinggi, what should happen to the pressure? Pressure tinggi, betul? When the pressure is higher, the rate of reaction will be always higher. That's why I'm giving you a lot of pressure. So that your rate of study will be higher and the rate of getting A will be higher. Alright? Human being, your entire life is about a reaction. And it's your choice to be hibernate in a cold temperature, stay comfort, doing nothing, okay. Lepas ni ada boyfriend nak kahwin, lepas matrik saya nak kahwin dah. Hai, nak kahwin senang kahwin. Being a mom is probably the hardest job ever that you'll get in your life. Being a parent is the hardest job. And make sure you're sending in a good batch of children for me to teach when I'm going to end my career. Alright, you're at the age of 19, 20, so coming to the end of my career sebelum saya pension, if I'm still able to teach, kalau saya tak mati sebab mengajar apa lah, okay? And I'm looking forward to teach a good batch of students because it should be coming from you, the so-called educated, digital nomad pupil. So they should be way better. Because some of you are still coming from parents that are probably did not finish their studies or struggle in their life and so. But your children should be very competent in everything. So I'm looking forward to teach them and make sure they are good. Faham? Kalau tak aku cari hampa lepas 20 tahun. Make sense? Agree or not? Okay? So in life is entire chemical reaction. So be good, do well, get a good product. Alright? And then we have temperature and catalyst. They are also directly proportional. Kalau kamu tengok nota saya banyak adalah cerita satu je, how do I increase my rate of reaction. Okay, kalau kamu tengok nota saya semua positif. How do I increase my rate of reaction? Just a kind reminder over here, to decrease the rate of reaction will be the vice versa of everything. Okay, it will be terbalik. So kita ada a few more minutes, I can still go in. Okay, kat sini, satu slide 1 minit. I want you to find similarity. Baca ayat the slide ni. I only have 4 slides to finish off. Okay. Kalau yang dah baca dah. Okay. Setuju ke dengan apa yang saya tulis? Kalau setuju, betul kan? I might get wrong. Kalau jumpa apa-apa yang saya buat salah, I'm okay with question. I'm okay with you point it out. Okay, don't worry. Everybody do mistake. Sometimes we need to do mistake to learn. Okay. Saya nak cari apa yang sama ya. Bear that in mind. My question is about similarity. Dah? Next. Okay, seeing the flow. Next. I want the similarity. Okay. Dah, setuju? Okay. Last. And on this slide, can you tell me among the 5 slides that I've given to you, because you have 5 factors, all right, what are the same? Okay. The last 2 points, if you realize, some of them are having only 1 point. Some of them are having only 3 points, 3 discussion. Some of them having 4, depends on the factor. Hanya temperature dengan catalyst dia ada 4 points. Okay, the rest of them ada 3 points. And if you look at them, I make my notes easier for you. Everybody don't like explanation. All right, I don't know, some of you might like it. I'm not a big fan of explanation. Okay, and to make your life easier, first thing, everything I say is positive. Everything that I aim for is rate of reaction increase. Okay, we are going for the same thing. Saya nak kadar reaction saya tinggi. In the other words, I want to produce more product. Okay, so you are going towards the same direction. Second thing, kenapa tak statement ni sama? Because we are going to the same direction. We want to increase the rate of reaction. We want to increase the product. So how do I increase the product? Remember collision theory? In your 1.2, that's why I say they're related. So your collision theory, when they collide, first and foremost, you need to collide. The more you collide, barulah the frequency of the effective collision will increase. Kenapa ada 2 statement? Back to your collision theory. Okay, minggu depan baru kita bincang pasal faktor-faktor ni. Saya nak bincang yang berkaitan dengan collision theory dulu. Dia bila berlanggar, dia tak semestinya berlanggar dan hasilkan produk. Remember? Dia kena berlanggar and it must be the effective collision. Yang tenaga cukup, correct orientation, baru dapat produk. That's why collision and effective collision are 2 different things. Make sense? Jangan terus hanya tulis, biasa budak akan buat salah senior-senior kamu, collision increase, so rate of reaction increase. No. Collision will not necessarily give you product. The one that will give you product is your effective collision. Make sense? And so coming back next week, what we are still going through these 5 slides. One thing I want to discuss, the 2 points up there. Okay? First and foremost, balik baca, jangan rasa benda ni susah. Untuk setiap satu faktor, bukan hafal 5 ayat atau 4 ayat. Tak. Kita hafal 2 ayat je. Sebab ayat 2 tu kat bawah sama. Boleh? So go back and of course the next class akan ada orang bagi tahulah kat saya what they are. Alright, attendance please.